All right, we have reached part 3. So the first couple of parts dealt with the factor theorem. Now we're going to talk about the remainder theorem and evaluating functions. So let's read through and see what our directions say. Notice that you just used synthetic division to reduce the polynomial so it could be factored. We did that in part 2. We read about synthetic division. I taught you about that. Now we're going to do the remainder theorem to evaluate functions. The remainder theorem, simply stated, says that the remainder in synthetic division when dividing by some value r is the same as the function evaluated at r. So we're going to use synthetic division and compare the remainder to the answer when direct substitution is used. And we're going to follow the steps below. So I've already saved ourselves some time because I trust that we are good at synthetic division at this time being. So I've already gone through and I did synthetic division 3 times. So number 1 says given g of x, so this is our function that we're working with. Everything is based off of this function. By synthetic division, divide by x minus 1, x plus 3, and x minus 7. Again, I trust that we are good at synthetic division. I've already gone through and did that for us. I divided by x minus 1. 1 goes in the box. We do our thing. We divide by x plus 3. Negative 3 goes in the box. Do our thing. X minus 7, divide by 7, synthetic division. So now these are our answers when I did synthetic division. I already did that part. Now this is the remainder theorem, so we're only focusing on the remainder. I got negative 48 when I divided by x minus 1. I got 40 when I divide by x plus 3. And I got 9,360 when we divided by x minus 7. So, boom, we'll keep that in mind. That is there for us. Easy peasy. Now let's see what the next part says. B. So part B says by direct substitution into the polynomial, find g of 1, g of negative 3, g of 7. So I kind of wrote out in words what this means in case we didn't understand that. That means we want to substitute 1 into our function, see what we get. Substitute negative 3 into our function, see what we get. Substitute 7 into our function, see what we get. So this is the function that we're working with. I plugged in 1. I plugged in negative 3. I plugged in 7. And then Desmos helped me out because there's a whole lot of mental math to do. So I typed all this into Desmos. I got negative 48 when I plugged in 1. When I plugged in negative 3, I got 40. And when I plugged in 7, I got 9,360. So I did substitution. This is direct substitution. Take a number, plug it in, evaluate the function. Now, part C says, compare the results and state your findings. Well, hopefully you remember these numbers, negative 48, 40, 9,360. So let me zoom out. Let's look at these numbers here. When I did synthetic division with x minus 1, 1 goes in the box, I got negative 48. I plugged in 1 down here, we got negative 48. X plus 3, negative 3 goes in the box. I got 40 as the remainder. When I plugged in negative 3, I got 40 as the remainder. Last time, just in case you don't see it, x minus 7, 7 goes in the box. I did synthetic division, I got 9,360. I did direct substitution, plugged in 7, I got 9,360. So our findings that we should definitely see is that you'll get the same remainder. So this is the take-home point for the remainder theorem. Write it down, star it, highlight it. You get the same remainder whether you do synthetic division or direct substitution. So that is the take-home point for the remainder theorem. Whether I do synthetic division with 7 and get the remainder, or whether I just plug 7 into my function, I'm going to get the remainder. So this part down here for part B, this is called direct substitution. And the part above we've been doing for a little bit now, that was synthetic division. So this is what the remainder theorem tells us. It also gives us ordered pairs. X is an ordered pair, we get y back out, negative 48. X is an ordered pair, we get a y back out. This is an ordered pair, we get a y back out. So if I write those ordered pairs out, we plugged in 1, we got negative 48. I'm going to write this in red. So my ordered pair is 1, negative 48. And that's 1, negative 48. I'm writing in red. Plug in negative 3, we get 40 back out. So negative 3, 40 is an ordered pair. Plug in 7, get 9,360 back. Plug in 7, get 9,360 back. So substitution and synthetic division gives us ordered pairs. If I graph this polynomial, it'll definitely at least pass through 1, negative 48, negative 340, and 7, 9,360. But the most important part from this little part 3 section is that you get the same remainder whether you do synthetic division or direct substitution. That is the take-home point for the remainder theorem.